can do this much faster. I wanted to work with a half, but that's a special character, so we have to use an array with 0, a half, and a 1 in it, which means I need to work with indexes, and the indexes then run from 0 to 2, 0, 1, and 2. Therefore, I might as well work with a cube, 0, 1, 2. Or maybe even minus 1, 0, well, minus 1 and 1, and then I can use 0 instead of half. I guess that is the easiest thing to do, but I don't like to print a minus 1 because it still looks a lot like this. Kind of used by the let's use this and I'll use them as indexes. But this is my cube. I still run over all corners, but now I want to be able to convert these to an index of 2. In other words, I'm just gonna destruct corner. Well, these are corners, so it just doesn't exist. It's just always 2. That's 12, I guess. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How many are this? Okay, actually looks like it's all of them. So 0, a half, or 1. That would be 27 or not? I'm gonna count them. No, I'm not gonna count. $20. What? I mean, minus this one. Why 20? Oh. Yeah, the 8 corners plus 12 edges. Because you also have stuff that is probably made up of twice the same corner then. No, must be. Should be. C has bit D not set. I mean, that is equal 0. Therefore, ORing it changes it. Therefore, we only create edges from 2 different corners. Therefore, there is always 1, 0 and 1, 1. And that should always give at least 1 half. How the hell am I ending up with an edge with only 0s and 1s? Very difficult. Shouldn't be that difficult. It even begins, the very first one is already wrong. Oh. Yeah, okay. I'm also printing the corners, obviously. Let's not print the corners. And then, of course, we get only the edges, wedges, and 12. Yep. Okay, so we have 12 edges, and now, what was the trick? Step 1, pick any of the 12 edges. So maybe I should just put them in an array. Hello, protein spider. Are you eating spiders for the protein? Alt top. Or just this, of course. We have them in an array now. Is anyone interested in what I was thinking here? Let me read it quickly. So the AI here came up with a difficult program, I think. Basically calculating angles and then just sorting them. In the end, anyway, I think here. Sort angles, yep. So I'm still feeling that there's a smarter way to get this result, smarter than calculating the angles and sort them. Of course, it's not worth the gained performance of the code, but it is interesting to think about it. Going from corner to corner of the polytope. Now you want to know what a polytope is. I still have this open. So we're talking about explicitly now a three-dimensional cube instead of n-dimensional hyperspace cubes. It makes things a lot easier, doesn't it? You can just see it here. We have a cube and we have a plane, and the plane is intersecting the cube. That results in one of these gray things, which are called polytopes. This polytope is a triangle, has 3 corners. This one has 4 corners, this one has 5 corners, this one has 6 corners. And this is a special case because it jumps from one edge all the way to the opposite edge on the same face. While here actually does the same thing, but here it only does that. In the case that we have 6 corners, every time we follow an edge of the polytope, we are staying on, well, obviously we are staying on this one face, but we go within that face from one edge of the face to a connected edge of the face. Yeah, so the face is a square here. This edge here is not connected to that edge because it's all the way on the other side. This one is connected because it has a common corner. So here we have, if you follow the edge of the polytope here, then we go from this edge of this face to that edge of the same face, and those 2 edges share a corner. And that happens every time. Here, this is the common corner, and here, this is the common corner. And for this thingy, that's the common corner, and for this thingy, that's the common corner, and so on. Now, you got that picture? How many viewers did I lose? 1. Yeah, that's what I mean. Never explain anything. It's just a waste of time. But okay, I'll try anyway. So here, what is my code? Grok. Go here. So going from corner to corner of the polytope, we are traversing lines that travel from one edge to another of the same face of the cube. See, it's super easy. I just explained it. In the case of the maximum number of visited edges, 6, this traverses from edge to edge, which each time those 2 edges share a corner, like I just showed. For example, let the cube be, well, have a corners with coordinates 0, 1. I should probably put a 3 here. It's just a 3-dimensional cube. Now we could have a polytope with corners, well, for example, these 6. And then back to 0, 0, 1/2. Each time between 2 polytope corners, we stay on a face of the cube. Exactly 1 coordinate doesn't change. For example, for the first one, we go from 0, 0, 1/2 to 0, 1/2, 0. I can't show that because I didn't draw that here on a piece of paper. Although I could point it out here, I guess. Let's say we go from this one. Imagine that this point is actually halfway here. Then this is in this direction 0, for example, and in the height direction 0. and in this direction it is a half. And then that point could have 2 zeros as well, but another dimension is a half. Now the vertical one is a half. So you can go from 0, 0, half to 0, half, 0, for example. Oops. Hey, that's exactly what I have here. So the coordinate that doesn't change then is the first one, and let's use x, y, z. Then the x coordinate stays 0. Yeah, so that is the face. The face is defined by x equals 0 is just one of the faces. We have 6 faces. X is 0, x is 1, y is 0, y is 1, z is 0, and z is 1. Each point is somewhere on an edge, denoted with a half here, but it could be anything between 0 and 1. Since we're not traversing to the opposite edge of a given face, in the case of a polytope with 6 corners, never will a 0 turn into a 1 or vice versa. Thus, giving the starting point 0, 0, half, there are 4 possible edges that we can go to. 2 where we stay on the face with x equals 0, and 2 where we stay on the edge. That's a weird jump, I would say. Yeah, this is just a face. What is happening? Typo. So either we stay on the face with x is 0. We're starting from here, yeah? So x is 0, we have an x is 0 and you have a y is 0. Thus we are on 2 faces at once, obviously. Like this point here is on the front face as well as on the bottom face. And then we can stay on the front face or we can stay on the bottom face. So, you know, go clockwise or anti-clockwise over the polytope. So if you go from 0, 0, half to 0, half, 0, well, you can do that, or you can go from the same thing to 0, half, 1, or you can go for the same thing to a half, 0, 0, and finally you can go from the same thing to a half, 0, 1. Those are all possibilities. Those are 4 possibilities, because again here, if you, let's pick this one, this is so close to the edge. From here you can stay on the front face, go there. You could also stay on the bottom face and go there. Because my mouse should be under the gray area now. I mean this line here. Or you can stay on the bottom face and go there, or you can stay on the front face and go there. Yep, there's 4 possibilities. The polytope always only shows 2 of the possibilities, but maybe this one. So from here we can go there, but we also could have gone there or there. Because at least then they are visible. But then I say the polytope edge 0, 0, half to 0, half, 0 is only compatible with the 0, 0, half going to a half, 0, 1. Namely being on the edge 0, 0, half between 0, 0, 0 and 0, 0, 1, thus the 2 corner points of the cube. Yeah, there are only 2 faces that we are on, the one with x equals 0 and the one with y is 0. A polytope with 6 corners requires to traverse both, traverse across Poor AI if I had entered it. Across both faces and well such that the coordinate of the two connected points that of the polytope that is not in between corners, so not a half, is different. I can show you that as well in this image. So if you want to have a polytope with 6 corners like this, then from this point you can stay on the front face. Yep. But then not all, I mean, this one stays on the front face. Then this one cannot stay on the front face, because then you don't change all coordinates. You stay on the front face. So if the front face is y equals 0, then y doesn't change between this one and that point. All coordinates must change. Basically, this just means that if this one goes to the left face, then that one must go to the right face. I keep doing that. So it is uniquely defined that if you have 2 points, you can find the third one of a 6-sided polytope. Where was I? Well, let me just start here. So a polytope with 6 corners requires to traverse across both faces, and well such that the coordinate of the 2 connected points that is not between corners, not a half, is different. So one is 0 and the other one is 1. For example, if the point 0, 0 alpha and 0 beta 1 exist and are connected obviously, then the point on the other side of 0 beta 1, the other side in terms of polytope, can be deduced as follows. 1. The point 0 beta 1 lays on 2 faces. X is 0, x is 0, yeah, x, y, z. So x is 0 or z is 1, and z is 1. The edge 0, 0 alpha to 0 beta 1 lays on the face x equals 1. Because the x doesn't change. Therefore, the adjacent edge must be on face z equals 1. And we can choose between some gamma 0, 1 or some gamma 1, 1. Now, because we go from here and the z must stay 1. The 0 must change and cannot jump to 1 because yeah, well, it's not allowed. So there must become a gamma. And the beta can go either to 0 or 1, theoretically. So that's the one in the middle, either 0 or 1. However, all 3 coordinates must differ from the point on the other side, the 0, 0 alpha. So it cannot be a 0, it must be a 1 in the middle. Therefore, it has to be gamma 1, 1. Let's replace the alpha, beta, and gamma simply with a half. It's general enough. Then we can generate all possible cycles as follows. Pick any of the 12 edges. Then pick any of the 4 adjacent polytope corners that share a face with the edge of 1 here. And I'm going to write a program for that. I think I made now a vector with all 12 edges. We're going to pick any of them. Well, I'm just going to write a loop that runs over it. Polytope edge, whatever. No, it's not polytope edge. That's only 6 edges. This is a cube edge. and of the 12 edges of the cube. Two. I pioneer ook 4 adjacent polytope corners. What happened here? NEO looks like a copy of that. No, the O actually not. Actually, the NE is also big cat. Hey, we found it. Okay, I don't know what happened. Pick any of the 4 adjacent polytope corners that share a face with the edge of the first one. I can only pick them if we know which one those are. How do I generate the 4 adjacent polytope corners? Yeah, for example, this point here is in between that corner and that corner. Then we can first go to that corner and then go either down half or go here a half, and then also on the other side. So we go here and then we go follow the other edge, or we follow this edge. So each time we must know where we came from, and then we go we follow the edge of the cube, follow the 2 other edges of the cube. For that I need a bit mask, or just the number. I do have the number, I guess, so I can run over all coordinates and then find which coordinate is a half. Hey, a nicer picture. Oh, that was an accidental click. I just want to go here. Yeah, it's a bit too much here. Bit masks, I was just 3 bits. I think I'm just gonna run over all 3. So basically we want to find... no, we want to run over both corners, right? So... yeah, let's create both corners. Find the 2 corners. Between which this edge, well, is, I suppose. Very confusing. I should replace a few numbers with const expression, variables, things. Create a corner from the edge. You won't believe it, but there's no longer a corner then. But then we just fix it by setting the value index that was equal to 1 to this new value. Hello, Roma. Yeah, why do I do the broadcast? Because it helps me concentrate, I guess. Not much other reason. And no, I don't have a job. That is, I don't work. I do what I like. Which is this? If this compiles, right? I mean, yeah, I had a feeling. Cannot construct a corner from an edge. Now the edge is derived from a point. So I could construct a corner from a point if I didn't have this, I guess. So yeah, I'm just gonna add it. Nah, maybe a bit weird. I don't know. Let's just do using points. Just allow arbitrary constructions. That still doesn't work. Hmm? Okay, these are just printing all 12 edges. I'm no longer interested in that. Let's print here. Let's print the edge. And then here print the adjacent corners that we run over. Let's see if that works. And I want to know which is which, so I'm gonna indent this thing a little bit. Yeah, I remarked half as a joke 2 days ago, I think, that someone asked how many years experience I have, which is 49 years, of which 31 years in C++. And then I joked that if it hadn't been that much, that I would have felt an asshole for streaming what I'm doing. What gives me an excuse to say, hey, you know, maybe maybe you have something to show. You don't know. Okay, well, that looks like it worked. So you have any of these points, and well, the two corners that where this edge point is in between is obviously yeah, the one where this half is either 0 or 1. So that is doing well, that not yet actually. So no. So I have this point now, and now we have this edge and that edge, and now from either of these edges you have to follow the so one of the other two dimensions must be changed into a half, and that's again a loop of 2, and then in total we find 4 other edges. So change the other 2 dimensions change one of the other 2 dimensions into a half. To find an adjacent corner. Yeah, that's. I mean, now yeah, I could say even more. I think I'm more special than just having 30 years experience. I'm also having a very high IQ. That is, let's keep it at that. But then it sounds like I want to show off, and that's definitely not the case. It's just for me. It's purely I can concentrate better, and it would at most it's like, yeah, you know, if it would be just a bozo doing look what I can do, and only my mother would be watching, that would be kind of sad. But I'm so self-secure about what I can do and what I have done during my life, that even if I have 0 viewers, it doesn't change my it doesn't change the fact that I'm convinced that it's I don't know. But yeah, that still sounds arrogant then. Never mind. Why did you ask that? Dang. Change one of the other two dimensions into a half. Okay, which dimensions? In this case, I was thinking about that bit mask, but it's kind of silly, so just run over all dimensions. Do I have a K free, I think? So K is my go-to for running over dimensions, apparently, in this little program. But if K equals the dimension that we already changed, and that would be the H, I think. Yeah, H has been changed already, so if K is H, then let's not do it. And otherwise, we can change. I don't want to change corner though, because you have to loop over it twice. So make this one const. Oh, and then I can't do that anymore. Okay, let's not make it const. Let's just create a new corner, which is not a corner now. Now it's an edge. Adjacent edge, and we create that from the corner. So not really an edge. Ha ha ha. Seriously. I want them to all be lined up. Yeah, I have everything on GitHub. Yeah, if you look at the description of my video, scroll down, I guess, then it's at the bottom, and that is the URL to this project. But the very file I'm working on now doesn't even exist yet. I didn't push it. But eventually I'll add it. And I have over 100 other projects, and most are aimed at production increasing stuff, like my utils, my debug output. Not really programs, definitely not graphical user interface thing. More libraries that you can use for your own C++ projects. Let me think. This should work if I add a constructor for edge as well. Did exactly the same way as this one. Allow constructing an edge from a point. And we don't have indentation. Well, you can see the half, but I want to have it right. I want to have more indentation. Oh, alright. I don't know what to make of this. I have only 2. That can't be right. Yeah, that's not right, is it? So you have this, and then we first change the half into a 0. And that's one corner, and then we change one of the others into a half. And then what is missing is 0, 0, half. Why is it not printing then? Oh, because this should be a 3. Dimensions, anyone? 3 dimensions, especially. No, it looks much better. Okay, so this edge has that one and that one as adjacent edges. Where in this case we stay on the z equals 0 face, and here we stay on the x equals 0 face. There should be 4 of them. Oh yeah, here. No, yeah. We can also first go to that corner and then change the other 2 in a half. Which means that in this case we stay on the z equals 0 edge, face I mean. And going from here to there we stay on the x equals 0 face. So in total we have 1, 2, 3, 4 possibilities. Bleep, blop, blop, blop. Yep. Pick any of the 4. No, we pick all of them. And then generate the next point from this pair. According to my reasoning here. And then we repeat that until we reach the first one, and then we have a cycle. And then I want to print that cycle and then do brute force all of them. Print all cycles. Yeah, so 12 times 4 is the number of cycles that I should get. Let's pick one and pick the next one, and then we can generate a whole cycle, I think. Therefore, I should get rid of let's print the whole cycle on one line, so I don't want to have a new line here. And yeah, like I can remember that. No new line, control flag. I have no idea. Yeah. Okay, let's test it. Does it compile? Does not compile. Oh, wow. The compiler is helping me. It is no new line. Well, could have been anything else, right? And then don't print the intermediate corner. But I do want to print this, and for that, actually, I have to print this again. So it doesn't really make that much sense to use the no new line. I just have to print both anyways. Yes, that should be, what did I say? 4? 12 times 4. Yep, 48 plus 1 for the top line. I'm kind of done with the entering main here. Right, okay, so next we want to have an arrow with the next point, and then keep that going until we reach the first one again. Well, then I still need my no new line. Yeah, well, it's all I know. Many people think I'm a complete idiot because I don't know anything else. I can't talk about this. So I try to have a social life, as in meet people in real life. And apart from the chess club, they're all, you know, the average on the street people. And you can't talk about anything, hardly anything, except soccer and the weather. Or I meet someone that is intelligent and knows stuff, and then I still can't talk with them because I don't know anything about that. I might be interested, like if I would meet an economist, then I'm all ears to hear how that works. But yeah, I don't know. And if I meet another programmer or anyone who is into C++ coding, then we also don't have anything to talk about because it's just too complex. The things that interest me. Now I know on the chess club, I know one guy who is an engineer working on difficult theories and the practice thereof, involving measuring distances using what is it called these days? So I have a bad memory as well. I don't know. Really, your phone it was 3 and then it became 4 and now they have 5. What the hell was that? Something 5. I don't have my phone here. I can't look at the back. But he's doing difficult stuff with interference and GPS things, and up till and including the relativistics. It's necessary. And I have abused him twice so far, talking about something that was on my mind, and he actually listened, and then even had an interesting. He was following what I was saying. But yeah, unfortunately, I can't say that it's a friend. You know, it was a real life friend. So it would be nice that I could talk about stuff with. But yeah, I don't know, man. Oh, you're like me. Yeah. Well, you can only be good at one thing, and if you are very good at it, then you have to dedicate your life to it. Like world champion chess. I don't think they can do much more than play chess. Someone in the Olympics. I don't watch TV. I don't read the news. I don't have a newspaper. I'm not interested in anything else either. Otherwise, I would waste time with that and then not put enough time in my computer, I guess. I have done, however, electronics. Quite a lot when I was young, yeah, as well. I have to admit, electronics was my main hobby when I was a teenager. More so than programming, I think, although, yeah, probably. But once I got really into programming, I completely stopped this electronics. Programming is so much nicer. Like, it's so exact. I just like things that are 100% exact. If there's anything wrong with a program, you can go down and down and deeper until the last bit. And you can always find out what is the problem. It is as exact and as deterministic as mathematics. That's why I like both so much. And that's why I use Linux, of course. No black box in my PC. My PC is a black box, by the way. No offense. What is it? I don't think I plugged the ears in, so I'm just kidding. I can't make jokes in English. It's stupid. Okay, here are we going to have a loop. Do. Calculate something. Print that too. And then repeat. And we repeat until we reach edge again. So let's say we make a new edge. They're all on the edge. You know? Just their edge here is a point, but it's a point on an edge between two corners of my cube. I already have edge. Maybe let's call this edge, and let's call the other edge a big start edge or something like that. Start edge. doesn't really matter which one is first. Could also make the free function makes more sense, but member function is less typing. I have more direct access to our array. Well, it's a struct, but still less typing. I mean, we have access anyway, but yeah, so just, I know, less typing. Next after. Adjacent edge. Oh, that won't work. No, actually it does work. Let's initialize this with start edge. And then, yeah, then I would skip one. That is not nice. I'm gonna call adjacent edge. Wait a minute. So already initialize this adjacent edge here then. So go in the direction of adjacent edge. It makes sense because the other one is called start edge. Nope, also doesn't work. I need two edges at all times. I don't want to change the start edge, so I need another one. And I can use edge and adjacent edge. See, so I need to use adjacent edge here, so I have to start with copying start edge. Unless I want to introduce just another one. At least now we have both, that is edge and adjacent edge, but then opposite is sounding a bit weird or not. So now edge is going to skip something. That is also not what you want. I'm creating a new edge, who cares? Edge, next edge. Print it right away. And then if we want to go to the top, then the edge must become the next edge, or edge must become the adjacent edge, rather. And adjacent edge must then become the next edge. Until next edge, but that's the adjacent edge is unequal start edge. A little ASCII art. Oops, what am I doing? Okay, so we run this on edge. What is then a good word for this? So we have edge, we pass adjacent edge, and they want to get next edge. Just next. I'm going to do next after. So you have edge, and then the next after adjacent edge is next edge. And then after that we set the edge to adjacent edge, and adjacent edge to next edge, and then rinse and repeat. Now we have to implement the hardest part, the member function next after. So that's going to be this one. Generate the next point from this pair. Yeah, okay. Deduce. If the points edge and adjacent edge exist, then the point on the other side of adjacent edge can be deduced as follows. 1. The point adjacent edge lays on two faces. We have to find the two faces that the adjacent edge lays on. Well, that's kind of boring one to do, because adjacent edge as the other two faces are exactly the values that are not k. Might as well pass k as well. No, actually, in this loop, I don't know that anymore. Let's not pass k. Let's just figure it out again. I am going to call it k again, though. So we loop over all dimensions, all 3 dimensions, and then if the current dimension is a half, okay, the index is 1, then it's not one of these two faces. Thus, last dot value index k equals 1. Continue. That wasn't too hard. What is the bloody word? It's not dot 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 a face. Defining. Well, indirectly it is defining both faces, but I want to have one, particularly one face. So finding the two faces, that would be enough to find k. Then we have found the two faces, nobody the other two. So maybe we should say find both faces, one by one. Can't think of the word. Instigated? No, that's not it. Is encoded is also not it. Represented? Pay me! Fuck off. Oh, can immediately get it back. Indicated could work. Specified, even better. Let's use specified, I guess. Nah, I don't like specified either. Fuck. No, what? But then what? Specified as depicted. Yeah. Identified, maybe. Represented. Maybe you should just use represented. Indicated. There we go again. Oh, wait a minute. I have to accept it. I thought it was an advertisement. It's that big, so big. Denoted. That could be the one. Yeah. Implied. Oh, even better. Conveyed. Oh, convey is a beautiful word. Indicated. Convey is pretty good. No, it's not it. Convey is something else. At least it's here. But it's still carry. Hey, signified is right here. That's what I said. Okay, I'll accept all. Convey as an idea. Meant, communicate or convey. Convey could still be it. Indicated. Inferred. Could be. What the hell is this? And it's still here. Sorry. There's another one. That's the last thing I wanted to do. Yeah, somehow they got advertisement on my Linux box. I think since a stupid upgrade of downgrade, I would say, Chromium. It's, advertisement filters are no longer working very well. Maybe I'll switch to Firefox. They used to claim that Einstein had an IQ of 160. This seems a bit nonsensical. These numbers are all way too low. Way too low. Nonsense. Last is on phase K. Yeah, okay. So K is now the coordinate of my face. And we loop over it and we get two phases. Then what? Two phases. The edge, this is the polytope edge. Polytope edge from there to there lays on the face x equals 0. Therefore, the adjacent edge must be on the face z equals 1. So what we can also do then is continue if the current thing is not equal to the coordinate that is equal between the two edges. So I have to find that one first, probably. Yep. Yeah, I'm just gonna call it a common phase, I think. Hmm. That's not correct. Let's apply this to my story here. For example, if the points did exist and we go from that one to that one, Yeah, so we have this with coordinates 0, 0, half, 0, 0, half, and last 0, half, 1, 0, half, 1. This is encoded by multiplying it by 2, so the half becomes 1 and the 1 becomes 2. Those values are stored in this array. The index of this array is 0, 1 or 2, representing x, y, and z. Thus, this is part of the phase x equals 0, because, well, x equals 0. And last is part of x equals 0, because, again, x equals 0. And because both are part of x equals 0, that is then the current phase. That is polytope edge is on. It goes from this to last, and all the while it's on the phase x equals 0. So the whole edge between those 2 points, between this and last. While here we can say, well, y equals 0 for this, and last equals a half, so that's not a phase. And here we have z equals 1 for last as the phase that it is part of. If the coordinate is a half, then k is not defining one of the two phases. Indeed. So continue. Now this, I think this was wrong. So we want to find both phases that last is a part of here, and we are skipping the half here. Leaving this one and this one, but you want also to skip this one, because that is the current phase. We want to find the other. And well, literally, current phase is 0, so yeah, if k equals current phase, then continue. So it is actually correct. That then leaves, for example, this leaves the z equals 1 phase. K is 2. Therefore, the adjacent edge, well, next edge, must be on phase z equals 1, and we can choose between this or that. However, all three coordinates must differ. So we still have to choose that one, and this one is that one comes from the fact that this one is 0. That has to be the current phase, I think. So the current phase always becomes a half. Yeah, of course. We are on the current phase. We have to change all coordinates, so you have to go away from the current phase. And we can only make steps of a half. Therefore, whether or not the current phase is 0 or 1, we have to go to a half. So the current phase always becomes a half. So we are constructing here the next edge. So we're going to have an edge called next. And here we find current phase. And then I can set that already. And the next adjacent edge must be on the phase z equals 1. Right? So this is a 1. And we got that from the fact that last has that. And at this moment, k equals 2. And the value of last is then what we want to use here. So we can say next value k becomes last value k. And then the remaining value, might as well do that after the whole loop, I think. But I need to know what the remaining value is, of course. So the remaining value is not current phase and not this k. So okay, let's do it inside the loop then. They still know what that is. The remaining coordinate then must be 0 or 1, but differ from this. So the remaining thing is, well, 3 minus k minus current phase. And that then must become 2 minus the value of current phase. Yeah, well, I explicitly say this here, so maybe I should just remove the last here. But they are the same, anyways, of course. Yes, and then we have next, and we can return that. We can't compare two edges. Brilliant. Okay. Yeah. Could add a counter that counts till 6, but I suppose adding a compare. Just add a compare to point. Boo. Bool operator unequal and make it different. I don't like those binary operators not to be a binary operator. So you get what I mean. Point constant reference left hand side and the right hand side. Return. Do I have an operator for array? Does array have an operator? Or definitely, of course, array has an operator. Dot value index is unequal the right hand side array thing. No match the constructor initialization of edge. You don't have a default one. Well, don't have to define it here yet, I think. So we might as well define it here for the first time. But even then, I still only have one thingy. No. Yeah, bull. Just add a default constructor. Winning equality comparison result unused. Huh? What? This needs something. Like that? Yeah, I suppose. You can fill in next as well, can you not? In this table. So this is the one that is equal, therefore it has to become a half. And this was this had to become 2 because I forgot. What is this one? Okay, is now 2, and we fill it with 2 because of this value. And the reason was that it is not one of the others. So it's not the first one because that is a half. And it's not, that is the first one I guess. And it's not the one that was a half in last. Yeah, so it's not this one and not this one. And this one then simply must be different from the first one. So this must become also 2. Not immediately clear how that works if you put it in the table. But yeah, well. Lots of output. Missing new line. We print all that stuff here. Using no new line, and then after this one we just have to print a new line. Oh, what is the notice doing there? Yeah, no new line is definitely not what we want here, apparently. I want continued, no new line. What I mean, really, I'm getting senile. Continued. But you can't use notice then. Okay, we get it. I'm printing notice continued with just the start edge. And then we said edge. Print adjacent edge. Can already use continue then here. Is it not possible to print this one inside here? No. Well, I could print adjacent edge here, yeah. Let's not do that here. Let's print that like here, for example. Start edge comes first, and then we print adjacent edge, I guess. Here. And then we calculate net edge, and then then we set adjacent edge to net edge, and if that is unequal start edge, we print it. So now it doesn't end with this beginning edge anymore, which is maybe even better. If you don't go in an infinite loop, then we know it found it anyway, otherwise it would not have broken out of here. Shocking. I would say it doesn't work. Why? Yeah, this is instantly wrong or not? Oh no, wait a minute, it's not wrong. So we begin with these two. Then, can I do this from my head now? So the ones that are equal must become a half. And the one that goes from a 0 to a half must go to a 1. It cannot become 0 again. And this one? Oh yeah, no. Isn't this the example that I started with? No, I didn't. Let's find the example case. See if that worked. We work so hard on the example. The example is 0, 0, half to 0, half, 1. Zero, 0, half to 0, half, 1. And then you have to go to a half, 1, 1. This one. So that the first step is correct. 0, 0, half and 0, half, 1, yeah? Yes, and that has to go to a half, 1, 1. So this was generated correct. Can I still remember why it had to be there like this? The reason was that yeah, the common value goes to a half. I remember that one. And the half goes to 1 because the 0 here was already taken, as it were. That would be this one. Pretty sure Z is 1 was the thing that we said first. And then, no, that can't be because this is a half. Oh, it took it from there, yeah. So this is just different from that, as in the remaining coordinate. That would be the 3 minus 0 minus 2 thing, which is 1, which is y, and the 2 thing is z. 2 is then equal to the k inside the loop, which is where this one is set. And that was set to 2 because it is set to the same value in last. And that happened because we can't use the one that was common, and we skip this one because it is a half. I think that's the reason. Yeah, so the first x is common and y is a half in the last one. Therefore, that one must be copied. The common one becomes a half, and this one is different from the value here. That's the algorithm I tried. So can we apply that here? The common one is 0. That must become the half. The half cannot be used, so the first one is copied. And the remaining value then is the one in the middle, which must be different from the first one. So this one is also okay. And here we have the common one, that is the one in the middle, becomes the half. You can't use the half, though the first one is copied. And the remaining one is different from that one. 3 on a row correct. How long do we continue? Well, we could, for example, see if this indeed is... this one is correct. Yeah, and then try to find the next one. Because this one terminates way sooner than I had expected. So here the common value is 1. That must become the half. This one is half, so we can't use it. So this one must be copied, yeah. And then the remaining one must be have the opposite value of that one, which is not the case. The common one becomes a half. This is the common one. You can't copy the half, so we copy the 0. And then this is the half, this is the one that we just copied. Then this one must be the opposite of that. Yeah, it's wrong. This one is wrong. Yes, the fastest way is to just debug this. Number 14. Well, after printing new lines. After printing 13 new lines. So the current phase is 0. That's true, these are equal. X is 1 is the current phase. We set that to a half. That would be that half. Do we skip X? We apparently do not skip Y, because we have to skip Z then, I suppose. Yeah, it is Z, that is a half. This sets the Y value equal to the Y value of last. Yeah. So this 0 here is the copy of that one. And then we have set those two. And this then goes wrong. Current phase is 0. K is 2. K is 1. K is 1. Okay, 3 minus 1 is 2. So we already have set 0 X and Y. Now we're going to set Z. You have set X and yeah, Y is copied. So we're going to set Z. And that must be the opposite of that value. Current phase is still 0, right? And this is 2. But is 2. Yeah. So this should set that value to 0. But that's correct. And I'm printing. No, wait a minute. There is a 0 here. This should have been 0. What? Yeah, that's weird that it's printing 2 then. Why is this printing 2? It is 1. The Z value is 1. 0, half 1. Oh, it's the other way around. Yeah, okay. So the Z value is 1. Huh? X is printed last here? So confusing. Is that really how I printed it? No. I guess just better start over. Oh fuck, this is static. Oh, I'm so stupid. Seriously. Is this the same output? This is the value that changes. This is a stupid static variable. Set print static off. Less confusion. X is 2. So X is 1, Y is a half, and Z is 0. X is 1, Y is a half, and Z is 0. That's it's X, Y, Z. So current phase is the X one. We have to keep scrolling up. Let's not do that. Let's just copy it. I might as well just, well, let's, I don't know. Whoop. Yeah. So the current phase is the one that has the same value for this object and last, which is the 1 in the first field, which is the x coordinate, which is represented with the value of 0. 100% correct. Then we run over all values, and if the last is a half, aka the index is 1, and that happens for k equals 2, which is the z value. So now k is 0, that is the common one, you have to skip that. And you will also skip case 2, so this is case 1, which is then the y value. Yeah, and that we just copied, so now we just set it to 0. This has become 0 now. So at the moment we have x equals 1, which is a half, and that was set. Y equals 0, which is just copied. Oh, everything is good so far. And now the last one is still uninitialized. Should be set to 1, and that is the index should be set to 2, which means that this must be 0. And that is 0, 0. It must be 0, and that is the thing of the current. That's not the current phase, man. Yeah, this is wrong. It's doing current phase here, and that is wrong. Yeah, that must be the same as this. On A2. No, it works. Everything works. Good. So this gives us all cycles, and all cycles are indeed 6 long. And the reason I wrote this program and have these cycles, because I wanted to do some tests on that. But what? By now my brain is completely melted. It has been hours since I had that idea. And the idea is gone. But no. Well, I was typing here. Yeah, at this moment I still had an idea. I just wanted to write a program first. Stupid. I should have written down the idea. What? Let me delete in peace. Oh, it starts there. Well, whatever. Yeah, I'm going to think for a bit about what was my next idea. I think these are duplicates, right? Because they rotate one way, but probably also the exact other way. For example, if you have these two, um, I mean, a cycle is a cycle. If you start with these two, then that is the next one, and so on. So we have an enormous duplication. Each cycle in this order is produced 6 times. And probably also in the reverse. So we can just divide the number of cycles that is printed by 12 for start. And then have an attempt at an analysis. Yeah, let's type that. This shows that the 1/2 rotates twice. Either clockwise, well, clockwise. Either left to right or right to left. That is the right way to describe this. I hypothesize. Is that a word? No. Dice? Nah, damn. I hypothesize. Come on, that must be a word. Hypothesize or something. Hypothesize. Put forward as a, yeah, isn't that not what I typed? Just nothing is part of my dictionary. Ridiculous. No, I did type it wrong. I hypothesize that if we reverse 2 points, that we get the exact same cycle in reverse. Also, more obvious, if you start with 2 well, let's call them adjacent points in a cycle, with, I mean, any 2 points in a cycle, you will generate that same cycle. Therefore, we can degenerate, is that the correct word here? The above (48). So divided by 12, that's 4. And above 48 cycles. Let's see, we have I have a 0 or 1 here, and a 0 and a 1 here. That's 4. And then we can have the half here, there, or there. So that's 3 times 4. That's 12. Well, of course. Yeah. So we start on any edge, and then these are times 4. Yeah, 12 times 4 is 48. So by factor of 12, to get only 4 more or less unique cycles. Which might be slightly easier to analyze. I'm gonna hit enter here because otherwise I type so much that well, let it think about this, and then maybe I'll ask a question at some point. I didn't even ask a question actually. This is just I'm not even interested in what it has to say. Let's just go do that. So first of all, it should be that we generate this cycle also here, and we do. And only there, obviously. And that one. And that one. But yeah, that's just too trivial, huh? I mean, a little bit less trivial maybe. If I select any 2 points, then we should generate in the same order, the same cycle. So I should get these 2 points 1, 2, 3, 4, 5 times. If I highlight it, 1, 2, 3, 4, 5. And then of course one time where this one is lost, half 1, 1. Here. And then 1 half 1 on the other side. Oh, wait a minute. Half 1, 1. Yeah. Oh, yeah, no, there's 4 possibilities theoretically, so it must be somewhere else then. You have to look for this at the end, and then there will be one that has that at the beginning. So 1 half 1 at the beginning. And there is not. Oh, wait, sorry, there is. I just have to find it. 1 half 1, so here it is. Yeah. But I'm more interested in testing the reverse hypothesis. How do we test it quickly in the program? I guess I can just store all cycles and then brute force it. It looks like the easiest way. Well, you can see the rotation direction, as it were, from the halves. So that here the half shifts back. So this is a right to left rotation. And then we have a left to right rotation. What if I begin with storing all the left to right rotations, like this one, in one array, and then the others in another array or vector, and then of course they should be equivalent if I reverse them. So then I just reverse them, and then we can compare it, and then it should be exactly the same. Yes, that would be the fastest way, I think. test. So let's make a new class called cycle. Which exists of edges, right? 6. Data, whatever. Point. Edge. Edges. Corners. Polytope corners. Yeah, edge is quarter than polytope corners. It's a cube edge. Well, let's give it an current size. The number of points, or n, I don't know, n, len maybe. Current len, okay. The default constructor initialize len as 0 and the array as whatever. And then we add edges to that. So edges len becomes edge, and then we increment len. Beep beep. I already have that built in, actually. They build it into the library these days. So. Range checking. Don't even need this. If you try something that is larger than 6, it's already going to complain. Runtime. Yeah. The hot breath of Rust, I guess. For whatever reason they had. I did run into it several times though. Kind of helps. Okay, so make a cycle, right? Okay, now it gets annoying. Let's move this one up. To above main. Let's put it there. And then here we are going to create a new cycle, yes. Create the next cycle. Cycle. Every time I print something, oh, you have to add it, or the other way around. Cycle, add, start edge. And then here you can do the same thing. Add adjacent edge. And now we want to determine the direction of this cycle. So left to right or right to left. So if cycle direction equals no, let's say left to right, left to right cycle. I'm so creative, it's unbelievable. Push back cycle. Else right to left cycle, push back cycle. So I put it in one or the other. And yeah, those things are almost global. Not really, but I seriously only need one of them. One of each. And then we have this for loop and that for loop, and I bet even that is a for loop. And then we do absolutely nothing except assert that the size is equal. For now, because I want to add the direction first. Not to mention the enum that defines this. Okay, so well, how do we determine the direction? Well, that means that we have to find where the half is in the first element, and then where the half is in the second element, and then we know it. So we run over all dimensions. And we're going to find the left or first, let's call it left. The left k, where k is dimension, of a half. But by now I use so much abbreviations that nobody knows what it means anyway. I could add an h, but or start typing over half and the right k. So let's add a comment. Left and right dimension. Yeah, I call it coordinate all over the place now. Coordinate. Like I would say dimension is maybe better because it's like 0, 1, and 2 for x, y, and z. And a coordinate is more like the value. Yes, maybe. But I don't know. I called it coordinate before. So the left and right coordinate, where the edge where two adjacent edges have the 1/2 value. I can't type 1/2. I have to find it again. Here's 1/2. Okay. Did I remember that thing correctly? Yep. So this runs over x, y, z, and then we test if x, y, or z is equal to index 1, which stands for 1/2. If that is the case, then we remember the dimension, okay, the coordinate, x, y, or z. And we do that for the first one and the second one. The rest rotates the same way. I'm really not even going to test that, I saw that. And then we can conclude which way it rotates, because return, if something is true, and the true then meaning rotating from left to right, I'm going to return left to right. Otherwise I return right to left. There's definitely only 2 options, I would say. So when is it left to right? Well, it is left to right if the LK, where the 1/2 is, on the left side, is equal to RK minus 1. Is that true? I mean minus modulo that I add after I check this. For example, if this one is 0, no, that's not. Okay, let's do +1. I'm such a pussy. Yeah, that is right to left. For example, if we have, you know where I copied this from. If we have this, and the last one doesn't even matter, then we would have left, as in LK is 1, and this says is 2. So if LK, aka 1, equals RK, aka, no, this is still not working. I shouldn't have used RKs too, because we add 1 to RK. Damn it. I'm just going to do the modulo thing right away here, so then we're done. Modulo 3. Where's my modulo? So RK is 2 plus 1 is 3, modulo 3 is 0. And if LK would have been 0 as well, so if the half was here, then this would have been true, and then we were rotating from what? Oh yeah, of course. So from here in that direction. So from right to left. That is correct. Hello, Nerai, I mean. Samont. I did this correct, right? So in this case, LK is 1, and this is 0, this is false, so we return left to right, and it's definitely going left to right here. Yeah, 50% chance. No, it's this is correct. I can just compile it. No asserts. So that worked. Hello, born vet. Yeah, is anyone interested in having a complete lecture about what I'm doing, or would I bore people that are already watching an hour? I guess I can keep it short, but I don't know. Tell me in the chat if anyone is interested to actually get explained what I'm doing. Oh, yeah, there's someone. Okay, man. Well, the thing is as follows. I'm trying to find a smart way, and it's pure because of the fun of it. The being smart and stuff. To find the intersection points between a plane and the edges of a cube. Did I already lose someone? You know what a plane is in a cube, but I have a picture of it. Let me find the picture. Yep. As you can see, there's a cube, and we have a plane as well. And the plane is intersecting the cube. A little bit, more, even more, and then in a little bit different way. I really wish they would have drawn this in front of it, because this polytope, as you would call it, is obviously inside the cube. Yeah, it's kind of clear. What this is, yeah, this line should have been continued. Here, here as well, and here as well. What can we do? So I'm restricting myself to this case, D, where the plane cuts through the cube in a way that it intersects with 6 different edges. These things are edges. You know, this is a face. We have a left face, right face, top face, bottom face, front face, back face. And we have 12 edges. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 12 edges. And we can at most cut through 6 of them with a plane. In this case, 1, 2, 3, 4, 5, 6. As you can see, the places where my plane cuts through an edge is exactly the corner of this polytope. And in all cases, yeah. So this is a triangle, and the 3 edges of the triangle are the places where this edge, and this edge cut through the plane. Now, what I want is I want to find all intersection points between the plane and the edges of the cube in an order that is cyclic around the polytope. So it could be that you find this one first, and then you find that one, and then that one, and then that one. That's random, yeah? No, I want to find one, and then I want to find the next one, and the next one, and the next one, and the next one, and the next one. In that order. I already wrote code that does that, and it does it as follows. We know the coordinates of all the corners, and we have an equation for the plane. Then the plane is defined by its normal and a point that it goes through. Yeah, so there is a single point somewhere inside the cube, in most cases. And we have a vector that is normal to the plane. So it's normal means perpendicular. That defines the whole plane. Yeah, the plane goes through that point, and we have the normal vector to that plane. Then I have a function that, given any point, gives me the distance to the plane in terms of the normal vector. So if you have a plane and you have a point that is on the same side as where the normal is pointing to, then that distance would be, well, in my case, actually negative, but whatever. My formula gives, I'll be honest, my formula gives the number of normal vectors that you have to add to that point in order to arrive at the plane. So if the normal points, let's say we take this plane here, and the normal points upwards, okay, so towards us, not to the back, but to the front. And then we take this point here, where my mouse is pointing. Now, think this line through. This point is on this side of the plane, so we have to subtract the normal vector that is pointing out of the plane. We have subtracted to get to the plane. You get that? That subtracting means negative distance. And points that are on the other side of the plane than the normal, you just add the normal until you get in the plane. So now we calculate the distance for every corner. And then if 2 corners have an opposite sign of the distance to the plane, then they are on the opposite side, which means that their edge must cut through the plane. So you have still a drawing thing, sketch bit. So if you have we have a plane here, and a point in it, and a normal vector which is perpendicular to the plane. And then if you have any point on this side of the plane, which is below the plane, and you have a point that is above the plane, then I have a function that calculates the distance to the plane, distance also being perpendicular, and this one also, distance. So this is a well, corner. Let's say this is a corner of the cube, and this is a corner of the cube. And the distance is, you would say distance is always positive, but it's not true, because this is my normal, and what it actually returns is the number of normal vectors that you have to add. So in this case, you have to add about a little bit less, I would say, one normal vector, a little bit less than one normal vector to get from C1 to the plane, yeah? Normal pointing that way. And in the case of C2, you have to subtract it actually, because you have to go that way, which is opposite. So this has a negative distance, and this has a positive distance. And if the sign of that distance is opposite of each other, then they must be, or then they are, on the opposite sides of the plane. And in that case, and only in that case, we calculate the intersection between a line through the 2 points. So now we can draw a line through those 2 points, and that intersects with the plane somewhere. And then, because of the sign trick here, we know that this point must lay between C1 and C2. Without the sign trick, we could have had another point here, which is also has a negative distance to the plane, like C3. But this would also have a negative distance, yeah, so also above the plane. But yeah, I can draw a line through these two, and that would cut my plane here. Yes, I mean, the plane is infinitely big. Right? So it would cut it somewhere, but not in between C3 and C2. And these are the corners of my cube. So I am only interested in actually cutting through the edge of the cube. So if this is my cube, like this, then I'm not interested in this point. I'm only interested in where the plane is actually cutting a corner. Well, this is not an edge actually. I should have made this an edge, of course. So you could use C3 and C1. Those two actually has an intersection between the plane and an edge. You know, this is not an edge from C1 to C2. There's a diagonal inside this face. So, but okay, the whole problem is to find those things. So now you understand that I can find all the intersection points simply by running over all pairs of corners and then calculating the distance to the plane. Look at the sign. If the sign is different, then I just calculate the intersection between a line and a plane. I mean, mathematics, but we can do that. And then I find those points, and will find all 6 of them. But in which order? Well, we have no idea. Yeah, it's pretty random. So I started thinking, is there not a way to do this such that I will find them in a cyclic order? I don't care which I want to find first, but if I find this one, I want to find that one next, and so on. Okay, so now I've thought of an algorithm to find them in a cyclic order to begin with. And that algorithm is, if you have this point here on this edge, then 2 coordinates are 0 or 1. Let's say the cube has, the corners of the cube all have coordinates 0 or 1. Yeah, so you have a 0, 0, 0, and you have all the way up till 1, 1, 1. And then this one has two coordinates that are 0 or 1, and 1 coordinate that is not 0 or 1, that's somewhere in the middle. And for simplicity, I just print a half for that value. So if this thing was in the middle, it would have been a half. Then how you can find, well, in this case, if you follow an edge of the polytope, you go through an edge, yeah. Oh, sorry, you stay inside the same face. And so this one is so on. There should be a line here and here, but let's use this one. That looks good. So if you go from here to there, you stay in the back face, and if you go from here to there, you stay in the bottom face. and here you stay in the front face, and here you stay in the left face. You always stay, all the time you stay in the same face. And in the case of having 6 corners of the polytope, it's even more special. You always just cut off a little triangle from some corner. So in this case, that is not true. You go from this edge to an edge that is opposite of the face. But in this case, you always go from an edge to another edge of the face that you are traveling in that has a common corner. Now, how many different ways can you go from a given point to a connected edge? Well, this thing has 2 sides, this edge, here and here. And then there are 2 connected edges from here and here, each. So this one and this one for that corner, and this one for that corner. So from here, we can stay in the back face and go to that edge, or we can stay in the back face and go to that edge. Or we can stay in the bottom edge and go to this edge, or we can stay in the bottom face and go to this edge. So every time you have 4 possibilities. Yeah. You can also go to the opposite edge, but then you won't get 6 corners. So I'm ignoring that for now. So then I thought, well, okay, so I take a point halfway each of the 12 edges, and then I pick one of the 4 adjacent edges that I can go to staying in the same plane. And then it is kind of already determined how, I mean, certainly if you restrict yourself to coordinates of 0, a half, or 1, how the polytope will look like. And I'm not going to repeat how the algorithm works that I thought of. That's this whole program. But I can show the output. That's this. So from top to bottom are 48 points on edges. I'm thinking hard why the hell it was 48. Why was it 48? Why not 12? Oh, because each of them repeats 4 times. Yeah, obviously. Okay. 4 times same thing. Yeah, you see. So this is one edge. This is a point halfway one edge. This is a point halfway another edge, and so on. And each time we have 4 of them, because from every edge there are four possibilities to go to one of these other points, as I just shown. So yeah, from each point you have 4 possibilities. So from here you can go there, or there, or there, or there. 4 possibilities. And then from each of the 12 edges, that's 48 pairs. So 1, 2, 3, 48. And the rest then is determined. You just, if you have those 2, you can calculate what the next one must be. Just trust me, okay? And I figured out the algorithm for that, and I wrote a program, and the program then outputs this. And it also finds that the next point after this pair is again this one. Yeah, so it is cyclic. And there are 6, indeed. Because by restricting myself to just cutting little corners off, instead of jumping to the opposite edge of a face, you automatically get a 6-sided polytope. The next step now was to make sense of this, right? So that in the end, this is a rather hard to understand algorithm, I mean, I can explain you even the algorithm. The algorithm works as follows. So we take 2 points and we want to know what the next one is. Well, that works as follows. First, you search for the coordinate that is the same between these two. And in this case, that would be the one in the middle. That one becomes a half here. Yep. Then you look at the last one, that is a half. And you strike that through. So the one that was the same as the one in the middle. This is a half, so that falls off too. So then that leaves the last one. Then you copy the value of the last point of the pair to the next one. And then we have the half here. We copied this one from there, and now this one then must be the opposite value of that one. So this is a 1, then this must be a 0. That's how it works, and that is applied every time, and then you get this cycle. But as you can see already, that there's a lot of symmetry here. Like if the half goes from here to there, then it rotates. This rotates from right to left, and this one goes the other way. A half goes from here to there, from left to right, and then around. Yep. So the half itself rotates from right to left or from left to right. And I think that, also, I mean, if you just take any of these 2 points, then you get that one. I mean, I now have an algorithm that generates from these 2, generates that. So if you start with these 2, you get exactly the same cycle, of course. If you start with this 2, you get the same cycle. Yeah, I mean, a half 1 0 follows, a half 1 0 follows, obviously. So each pair generates the same cycle 6 times, and I think if you swap the 2 points, then you get also the same cycle, but then in reverse. And that's what I want to test now. If that is the case, and it will be the case, then we can divide these 48 cycles by no less than 12 to get 4 cycles, only 4 cycles that are a little bit different than basically just exactly the same cycle. I mean, the same meaning that if you draw a plane through those 6 points, then you cannot distinguish the planes. Though I should say there are 4 different planes that you can draw through, apparently, through a cube. Really weird, I would say. Why 4? 3 dimensions, 6-sided cube. No, I don't see it. But yeah, I mean, that's going to come out of it. I'm curious what that means. Okay, by now everyone left, right? I mean, that's what normally happens. Yeah, everyone left. I think I had 5 viewers, and now I have 3 left. But maybe the 2 people that wanted to hear this are still there. Boronvet, Otero, tell me in the chat that you didn't leave without saying goodbye. I'll be so disappointed if you did. They seriously left, right? Oh, you're still there. Okay, that's at least 1. Whew. Okay. Now, I hope you have a little bit of an idea now what I'm doing. So, I'm going to split all the cycles that we find, so all the 48 cycles, into 2 groups. The one where the half rotates left to right, and the one that rotates right to left. I might as well print them. So here we come. This I did not assert. You could not follow what I explained? Oh, too bad. I'm just going to print both, just for fun, for start. So we loop over all elements of... oh hell, it is a cycle. We loop over all cycles. In left to right. And then we print that, print everything to debug channel notice, just print cycle. Cycle? Why would that not be cycles? It would be cycles, wouldn't it? This must mean, however, that what it means, I mean, that we must be able to print a cycle during the debug O stream. So I better add a print on standard O stream reference. And that then has to mimic the code that we already have, namely here. Something like that. This case, however, I do not have a start edge. I just have an edge. Maybe it's not that complicated actually. I probably have to use continue though. Let's just do the character const pointer separator, which always starts empty, and then we have a for loop that runs over all the cycles, all the edges. All the edges in edges, of course. Size. Well, let's just use the usual for loop. Why not? Edge const reference edge in edges. And then I just print something, and after having printed something, I set separator to this so that we can print continued separator edge, and we can print edges, so that should work. But before continued can work, we have to print well, nothing then in this case. It's a tiny little bit silly. Is an empty line there? Why did that happen? But yeah, left to right. So of course, left to right again, 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 again. That seems to have totally worked. And these go the other way. Yep. The print on is followed by a new line, so you should not print a new line here. That's not going to work then at all. I'm an idiot again. I'm a complete idiot. I always have this so-called excuse then that I have to go to bed. It's midnight, so I'm afraid it's much worse. I'm just getting old. Yeah, this is the equivalent of making a cup of tea and then putting that in the refrigerator, and then someone says, "What are you doing?" And you're like, "Huh? What? Oh, I should put the tea in the refrigerator." You take it out again and you drink it, something like that. Just, my God. Okay, anyway, this works, and now I wanted to sort them and then reverse one of them, and then they should be exactly the same. Sorting them is easy if we can if we have an ordering. I think I have actually a utility to compare arrays. I remember vaguely. This is also an array. So if I have a utility that compares any array, then I would already be able to compare these things, sort them. Sort of. Well, yeah. Where do I have that? A compare array. Oh, where the hell would I store that? In utils, I guess. But can't remember that good. Well, that gets close. I have a pair compare and a vector compare. Maybe I don't have an array compare then. A list compare maybe? No. Yeah, weird. I do have a vector compare, but not an array compare. I need an array compare. It's just a fact, man. Can't even ask codecs because that needs a Git repository, I think. Codecs are like really good. Maybe you can ask it a question without a GitHub thingy. This is part of transform, but I can just click on ask. Hi, I have please write me a usable array compare. That uses default that's nonsense. And that only compares arrays of equal size. So an error. Sorry, a compile error. Otherwise, because the requires is what? Yeah, I don't know. Compare doesn't exist, I guess. Yep, ask. It's still going to set up the environment. That's what I mean. This thing this thing does works with a certain code base. Right, I think it did it here as well, so we can close this. Copy codes. Array compare. It left out the pragma. Utils the type name element compare. Yeah, I mean, it should be correct. I have seen it write much more complicated code already. And it looks good as well. I can compare the two though. Because of course it should extremely much look like the one that I already wrote. If not like 100% equivalent. Yeah, if I want to make it exactly the same, I would have to remove these const references. I think I'm going to do that. Okay. Okay, great. Can this be used to implement a spaceship operator for I should remove this, I guess. Is it now going to change utils array compare? Oh, it adds it. Oh shit, I didn't say not to add it to the project. And then we can't find it back because the thing doesn't work with git submodules. Is it writing a test now? Surprise. Yep, it wrote an array compare.h with a pragma what. But we'll just use the one that we have. And this is an example. But actually, I think I just added an example to the project. So I'm not changing the project. Really, I'm not. I just added an example. No, that's not even super bad, as it were. Yeah, to this cap the unequal, which is I think okay. Spaceship operator only defines less than and larger than, and less or equal and larger or equal. Does it not also define unequal and equal? Not even sure. Hmm. Now let's just do reorder, and then always reorder it in well, starting with the smallest value, like always. Yeah. don't get it. I never use ranges, I must say. Okay, that before I ask this, I suppose I should test if edge does have an operator less defined. Oh. Oh, that's this one. Never mind that. Yeah, we do. don't see a weak ordering here though. I don't see a weak ordering. Well, strong ordering. Ridiculous. Well, in that case, I don't even need a point to be comparable. We only need edge to be comparable, really. So I'm gonna move this to edge and see if that works. Nope, still does not work. I didn't know that. Array has a less than operator defined? Out of the box? What? Yeah. No more ranges. Stupid ranges. That doesn't look good at all. What the hell is this? What did I do? Yeah, that appeared out of nowhere. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. One of the things just totally broke. This and this one broke. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. Okay, that's another one. 6, 7, 8, 9, 10. And then we have my reorder is broken. Well, who shall we blame for that? Me probably. Wait a minute. I think it's even worse than that. Yeah. Okay. Yeah, this is just horrible nonsense. How do I fix it? Sure. I'm still printing it. Nope. I go through. I thought it would be fun. Mm. I post. Yeah, I'm under the covers. I just have my flashlight still on. No, I go to bed at 2 a.m. these days. As a, 3 a.m. I just gave up going to bed early. I don't know. I just want to finish this. Damn it. Reorder. I need to write a reverse and do this append. Yeah, I thought so. Alt, top, find, home, append, standard vector, how to help me, appending a vector to a vector, concatenating two vectors, enter. Leave a lot. Copy back inserter, the under move elements, standard. I really hate standard ranges. Probably understand why. Yeah, no ranges. Let's do this one. Not because of one or of another. Okay, 97, yeah. Source, boop. Up. Source begin end. Back inserter destination. Really what I want. Might as well reverse it in a way that the first one stays in place, which means it is already reordered. Keep it reordered, why not? So I don't need this one. I'm assuming that that is already 0. And then the first one. Just like that, I guess. Hmm? So that's coincidence. No, this is already correct. Damn it. What is this? Why do I have 8 instead of 4? No. This thing is even not all the same direction actually. This one is right to left. And this is left to right. Guess this might explain it. So we do not do this copy. Then I get 4 of them, and they are all left to right. And they all already existed, hopefully. Yes. Yeah, I already explained it a few times now on stream. Getting tired of it. You just joined too late. Post bunny is cracked. It's too late. I have to go to bed. So. Printing the left to right cycles. Left to right cycles are processed last. Reorder left to right. But the right to left cycles have also been processed already. Let me just print those. Let's print the right to left cycles. And then print them maybe again after I reverse them to see if that went well. First time you join. No, I saw you once before, but I'm really coding a lot. This is okay. So the right to left, yes. The half is moving to the left. You see that? Rotating. And here as well. Here as well. Yep. Okay. I got distracted by 3 dimensions now. Yeah. I just couldn't help myself. This is an interesting problem related to a plane cutting through a cube. Yeah, I agree. It has nothing to do with what I was working on. Almost nothing. Right to left cycles. Reversed. Wait a minute. So we have this one. And this one should be the reversed version. And the reversed version should keep the first element in the same place. It definitely did not do that. Definitely did not do that. This is that one. That's correct. This is that one. Also correct. This is that one. Correct. This is that one. Correct. This is that one. Correct. And this should be that one. But it isn't. Plane in a cube. Yep. That. So for the coordinate system, we need a line in a rectangle, but I was solving that already with an algorithm that I wrote for n dimensions. And I wanted to change it now such that we get an automatically the correct order. So I know which intersection point is the one on the negative side of the x-axis and which one is on the positive side of the x-axis. aka the 2 intersection points of that one line ordered, either this order or the other order. It's flipping, of course, when you flip the normal of the line. But in multiple dimensions, that is the same thing. So 1 dimension higher, you have not a rectangle, but you have a block, aka a cube. And you don't have a line, but you have a plane. And the plane also has a normal. And then we have a cyclic order in which the corners of this polytope can be ordered. And the cycle should go the other way around if you flip the normal of the plane. But my current interest lies in finding a neat algorithm that generates these things in cyclic order. And I don't think it makes any difference where you put these points on an edge. So I just put them, I just make it, I mean, we are dealing with a block with 3 different sides and a plane random orientation. But the whole algorithm is the same for a cube with all 3 times the same size. And a plane only cutting through either a corner or exactly half the edge. That did completely the same thing. So I brute forced all possible ways that a plane can cut through a cube where it only goes through those half points in the edges. So this is not a good picture, but it's like a quarter here, but you should think that this point is halfway the edge, and this point is halfway the edge. This point is halfway the edge. Doesn't really matter. So that's this picture is then what I'm dealing with. And then this is a cycle where, you know, these are the coordinates of the corners of the polytope, aka the intersection points of the plane with the edges of the cube. And you can cut at most through 6 edges. And these are all the cases where that happens. So you always have six corners or a 6-sided polytope. And I made an algorithm, which I think is correct, where if you have 2 of those points, you can calculate the next one. So given 2 adjacent points and whatever order, you get the full cycle. So if we rotate this, I mean it's a cycle, right? After this we just go to the beginning again. So this goes around. I mean it goes around as in like this, yeah, there is no cut in the middle. So we can rotate the thing such that the smallest one, however I want to define that, and I want to define that this is the smallest one, if it exists, is first. Then we can make them unique. And we already go from 24 different cycles. I mean, these are all 48 cycles. But you can go from 24 cycles that rotate right to left or clockwise around the normal to 4 because they are the same cycle. I mean, the way I generate them, the starting point occurs at all 6 places, of course. But yeah, 24 divided by 6 is 4. And then if you reverse the cycles, then you get you get the same thing. So in the end, I should just end up with these 4 cycles. But I'm trying to combine the left to right cycles, or the right to left cycles here, with the left to right cycles. So the left to right cycles are these 4, and the left to right cycles are these 4, and the right to left cycles should be the exact same cycles, but then reversed. So first I try to reverse them, and that goes wrong. For some reason I end up with this instead of that. My reverse is wrong. Let me just fix the reverse, and then I can finally go to bed. Call reverse on the vector. That is here. We run over the reference of a cycle over every element of my vector, and then I call reverse on that. That should work. That calls this. And then I override my edges with the reversed edges, which is a temporary copy. Reversed edges. Yeah, well, you have 6 edges. So these are the corners of the polytope, but also an edge. Yeah, I mean, every corner of the polytope is also on an edge of the cube. So this is a corner of the polytope, an edge of the cube, and then I have an edge of the polytope, which is a line from one edge to another edge, but staying in the same face of the cube and not crossing to the other side. So this one here stays in the bottom face. This edge of the polytope stays in the bottom face of the cube, but these edges are not adjacent in the face. So it goes to the opposite edge of the bottom face. And if you do that even once, then you don't have 6. So I'm trying to crack the 6th one first, and then I will look at the other degenerated cases. And I'm again being an idiot for wasting my time, but hey, I claim it's fun, not having fun. Reverse. Why is that not working? Oh. Yeah, first I tried to do it in place. Come on, dude. I tried to do it in place. Wait, do it in place. No, I'm overriding also 0. Yeah, stupidity. Can we initialize this thing with... is it initialized already? No, let's just initialize the first one. What is stupidity? Stupidity. That's why I should go to bed. I just keep telling myself that it's a lack of sleep. I wish. Why is that highlighted? Why is it still highlighted? Stop highlighting. Oh wait, it's highlighted because I made a typo somewhere. But where? I don't see it. I don't have a typo. New Vim has gone crazy. Oh, now I see it. That was a typo. Good. Yeah, so now these are kept the same. And the rest is inverted, which means that the smallest edge is still in the first place, but the whole cycle is reversed. Therefore, these should now be exactly the same as these. So if I append them and then sort them again and I make them unique again, we should still end up with just 4. I think that is a nice point to go to bed, because then finally we have that. I add them now, I reverse them. I don't print them again. I don't print them here. I don't care. It's good with you. Reverse, append, and then sort all of them, and then make them unique again, and print that, and it's still 4. That is the idea. Yeah. And then of course I have to end my story with ChatGPT. I keep that informed of my progress. What is this? That's not what we were talking about. Oh yeah, I told it, I didn't read the answer, so I was like, hey, what is this? I told it about this, so this shows blah 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 blah. I should get only four more or less unique cycles, which might be slightly easier to analyze. And then it's thinking about, you've discovered the purely combinatorial walk. No angles, no sorts, just flip the right bits. Here's the clean way to see why it works and why it's guaranteed to produce the polygon cycle in 3D. It found a mathematical paper, I guess. I should... when do I get my PhD? Why the local rule gives a single cycle. What rules are it talking about? I gave it a rule and now it calls it a local rule. I don't have time for this. I think it agrees with me, right? It's like... degeneracies. Okay, and that becomes interesting. If the plane hits a what? No, that's a different degeneracies. Generalization sketch for enlarging. No, I'm not interested. Yeah, sorry I didn't read your answer, but I'm still going to bother the AI with my next. So after making all the 48 cycles unique, by reversing if necessary, we end up with 48 divided by 2 divided by 6 is 4 cycles. Indeed. I'll give the code as well. Strange. I just copied the last 4 lines. I really have to go to bed. Bloop. Oh, I turned off thinking. It turns it on again. Explaining the 4 cycles. What do you think? Do we see it? Maybe I would see it if I would actually see it in front of me, as it were. Maybe I should draw this. Can I draw this? Of course I can draw it. Damn it. Now I thought about drawing it and I can't go to bed until I did draw it. The structural facts about the successor map. Your next after implements. Why do I have the feeling that I'm close to explaining spinors of quantum mechanics? You have to rotate twice before it's the same again, aka spin and a half things. I must say it's a bit over my head. I think if I studied on this half an hour, this one answer, then I would probably understand it, but I don't have the time for it. So maybe we should just scroll to the bottom. Basically, 24 of the 4 comes from 24 divided by 6. That's what I get. And still I have to draw it. That did not erase everything. And then nothing worked anymore. Where's my new button? New. Yeah. Draw. How can I set, where can I set my color? So it's so unclear. No. No. How about this? Crop and resize. No. Select. Copy. Paste. Move. Is that going to work? Let's put it a little bit to this side, just in case. More lines. It's not really a block like this, but yeah. Text. Oh, way too big. Line width, line height, line spacing, word spacing. Where's my font size? Maybe line height. Yeah, that is line. Well, no. No, not really. Not really. Oh, that works. Well, it's a bit to get into it. It doesn't show my cursor. Why do I have the feeling that I've... oh, I just forgot 0, 0, 0. Well, I could have used this one. 1, 1, 1, 1, 1, 1, 1, 1, 1. Deselect, I want move. Where's my move? Well, I just have a move by. Let's just do line, or no, let's do text, and then hope that we can move it. Drag and move, yeah, okay. Let's call this 0, 0, 0 then. And then let's say X is here, so this would be the X one. That is then that. And then let's say that is Y, so that would be this one. And then we have, and this must be Z. Which means that this one, oops, should go here. And here we have this one. And this is the opposite of 0, 0, 0. And then the one that is left must go there. Yeah, really I need all the half points as well. Which is 12 pieces. See how quickly I can make those. Text. Oh god, we go like that again. Delete. Copy. Paste. My god, that worked. Yeah. Like this. Yeah, good enough. Control C, Control V. No. No. Undo. No. Okay, start over. Now let's just place it, I think. This 0, 0, half, it goes in between here. And then here we have, let's say, I need to make a few copies of this. Let me just copy. Control, no control. I don't believe in controls anymore. Paste, that's the second one. Paste, third one, and with that is 4, yeah? Something like that. 1. The 1 and the 1 and the 1. Now that one is 0, 1, a half. 0, 1 here. And then here we have 1, 0. That goes here. It's a bit unclear where that goes. This 1, 1. Yeah. Yeah, so they are on this. I need 4 more. Okay, ends on 1 1. That goes here. Oops. 1 0 is there. This is obviously. This obviously here. And then that is there, right? Yeah. I really need a color. How can I change the color, man? This. Yeah, something is red now. Nope, still black. Outline. Yay. Okay, 0 0 half 0 0 half 2 a half 0 0. And then to 1 a half 0. Gotta be kidding me. Sorry, I did it wrong. Zero zero half to a half 0 0. I'm looking for it there. To 1 a half 0. That's there. To, oh, really? No. Do you think we can change the transparency afterwards? Let me fill it in first. Hopefully that is going to work. Transparency. With transparency on more work. The next one is 1 1 a half. That is here. And then a half 1 1. And then 0 a half 1. That's here. Yep, that's one. And now let's hope that we can change the fill. That is not working. I have to select it first, maybe. Select. Change the color. Shit. Oh yeah. And I sneakily didn't close it. Monstrous. Thought I closed it. Just gonna draw one more line. I can be sneaky too. Right, okay. Next, we want to make it not text. Let's say green, and this one green. And then draw the line from 0, 0, half as well. Ooh. To a half 0, 1. A half 0, 1. That's here. And to 1, a half 1. 1, a half 1. Yeah. 2, 1, 1, a half. It's the same point again. Yep. To a half 1, 0. A half 1, 0 there. To 0, a half 0. There, and back. Yeah, okay, I see it. I see it. So you take two opposite points and then the other four are changed. Therefore, we have this one, that's 1, and then we have 2, and then we have these two opposite points, and we have these two opposite points. And they cling all together. Each and every one share 2 points. And every time the other two are changed. And that's how we get to 4. Super. Let me draw them in anyway, but I think I might even be able to do that now from my head. So let's put these things on blue. And then draw the next one. 0, a half 0. 0, half 0, 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 0, half 0. There it is. Wait. Where is the thing that I just did raw? I still see the points. Fuck, what the hell is this? Oh, X. Yeah, no, I lost them. God, what the hell? What the hell? I've got to select, I guess. So if we start with this one, then automatically we know that it shares the point with that one. Therefore, we have to go in this direction. And not the other. I mean, it's just two faces, right? And then we go to... Yeah, sorry. It's a horrible image. I'm gonna put it there. And then we get to the other one, and then this one must go here, I guess. Also opposite. And there and there. It doesn't even look nice anymore. I had to maybe move this point here, so at least it looks a little symmetrical now. Nah, it's not how it should look. I think I should. The way this is it's just a single line. Well, nah. Let me check it if I got it right. So we started here 0, half, 0, half, 0, and the next one is 0, 1, a half. Yep, 0, 1, a half, and then a half, 1, 1, half, 1, 1, yep, and then 1, a half, 1. 1, a half, 1, that's here, and then we should get 1, 0, half. Yep, and then a half, 0, 0. Yep. So I did see it correctly. Let me add the last one. Now, purple. And it disappears again. I forgot again. Well, nope, it's all gone. It wasn't visible anyway. It's just it's a diagonal line here. Let me draw in the last one. A 0, a half, 1. Here. 0, half, 1. Yeah. Okay, so that goes here. 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 Click there. Yes, thank you very much. Stupidity, that's what it is. At least now there is no choice. I already put them at a certain place. So I just have to go here. Okay, where do you go from here? Here, yeah. And then well, then there. And then back, I think. 1, 2, 3, 4, 5, 6. Okay. Yeah, unfortunate choice. Should have rotated a little bit. Nou ja. Okay, totally bad time. Good night.